So welcome everyone. Welcome to day three as well. So we'll start with Shayne. Has worked, collaborated with Cohere labs in various places, and multiple projects. Not only, yeah, I think first time I saw like we collaborated was through Aya and I was really impressed. So he's a PhD candidate at MIT, and his work research focuses on the intersection of AI and its impact on the world. He leads the Data Provenance Initiative and helped organize the open letter and AI safe harbor for independent AI evaluation and red teaming, and has contributed to training models, including Blue, Aya, and Font5, for example. Shayne has also collaborated on multiple projects with Cohere Labs, helping advance large-scale and collaborative AI. His research has also earned Best Paper Awards at ACL and NACL and has been featured in various press releases from New York Times, Washington Post, Atlantic, and so on. So I'm really honored to have you here, Shayne, and learning from you. The stage is yours.
Thanks, Julia. Thanks for a very lovely and long introduction. I have a lot to live up to now. I'm going to dive into it. So I'm really delighted to be here. Thank you so much. I'm going to talk today to build on the previous presentations about collaboration in AI research, but also research more broadly. And I want to talk a little bit about pave a roadmap for what it takes to have a successful research collaboration from what I've learned from my mentors, advisors, including many at Cohere Labs and elsewhere. And so to dive in, why am I here? I have been really fortunate to be part of some major collaborations in the AI space. When I was a junior researcher, I was collaborating as part of Big Science, which had hundreds of international collaborators to produce Bloom and Roots. And then later, as an intern at Google, there were 50 plus collaborators in an industry setting to put out the Flan collection and the Flan T5 model series, which at the time was the most popular open series of models right after the launch of ChatGPT. And then one of the best experiences I had was collaborating with Marzia and Amit and Sarah as part of, and many others here, as part of the Cohere labs that produced the Aya model, the Aya dataset. And I've been part of some smaller collaborations led by others here that have been phenomenal as well within that setting. But after that, I wanted to sort of launch my own collaborations. And so I started with the Data Provenance Initiative, which expanded to 50 plus contributors across 20 countries, where we did massive data set audits. And then later, a collective of academics got together to write an open letter about an AI safe harbor, which also ended up being co-signed by 400 scientists in the space, but was put together by about 40 researchers. And so altogether, I've had a journey of being part of amazing collaborations and then started to sort of plan my own, and I want to provide the learnings that I've had so that others can do the same. So the agenda is basically why should you collaborate as opposed to do something by yourself? And then later, can we build a roadmap step by step to do it yourself in a way that's successful? So the first reason why you should collaborate is that more authors plus more interdisciplinary perspectives roughly translates to more impact. So, you're all scientists, or many of you are, or aspiring scientists. And so, if we actually look at the science of science in this space, we see that people have tried to measure the impact of research as a number of, in terms of the number of authors on a paper. And it's not guaranteed, but on average, the impact across these metrics tends to improve with the more authors that you have. I don't think that's just because of self-citation. I think that's also because people actually learn and benefit from a variety of perspectives that can really hone work to be the best version of itself and maybe explore directions that otherwise one person wouldn't have thought of. But people have also looked at the number of interdisciplinary authors. So rather than just a team of computer scientists, what about a team of computer scientists with other disciplines and fields weighing in? And we see that actually it's this sort of bump curve, at least in the studies that I briefly looked at, where if you don't have enough interdisciplinary perspectives, your impact will be lower. But if you have too many, maybe it sort of saturates the variety of views that you have, and it's hard to make them cohesive or align. So really, you want sort of individual projects to have a variety of perspectives, but maybe not too many. Maybe isolate two or three different fields, bring them together to do something that's impactful in each. The second reason that you should collaborate is that AI impact is broader than it has ever been before, and it necessitates this type of collaboration. So, if we look at this map from the Anthropic Economic Index, we can see that there are over 1 billion users worldwide across, and this is our estimates, but across Gemini, ChatGPT, Claude, and Llama models in products and services that expose general purpose systems. And it's not just in North America and in Europe, it's also in South America, it's in Africa, Australia, the Middle East, and Asia. The only reason China is grayed out here is because they use some other systems rather than Claude. But you can, and same with, Russia and other places, but you can see how broad the adoption has been. We also look at ChatGPT economic records, and it shows that the daily messages per user is increasing across all user categories. And because these systems are so general purpose, they're not just being used to write essays or to help with your coding or math. People are using them for pedagogy and education, art, design, entertainment, office and administrative support, life sciences, sales, healthcare. They're using it as their therapists, as their medical diagnosis, as their legal advice, and sometimes as their companions in ways that are maybe misused and even abused. And so, across all of these new nascent uses, we need not just a computer scientist, but a computer scientist plus experts in these other fields to weigh in on how this can go right and how it can go wrong and how to do things better. So, I took the time to, or quickly, I'll summarize. AI is used more internationally, more frequently, and for both work and non-work related things in more ways than we could have envisioned. We see an acceleration of each of these, and so that means that there's a more opportunities for you to go and explore and hone and improve how AI is used and evaluated. So here I've enumerated some of the research questions that I've thought of over the last couple of months and been interested in exploring to give a sense of just the sheer breadth of things that are understudied and need interdisciplinary collaboration. And on the right, I've underlined and bolded the ones that I've already been fortunate enough to collaborate with. So I've worked with lawyers, economists, journalists, cybersecurity experts, and library scientists already, and it's absolutely benefited my perspective and my career and the impact of my work. But just to give you a sense and maybe inspire some questions here, and I'd love to see if others have some that I've missed that they'd love to share in the chat. But you can explore whether AI training might be violating intellectual property or privacy laws, whether it and how it's affecting the economy, the labor force, how it's affecting journalism, whether AI can be used offensively or defensively for cybersecurity. What about for child development and pedagogy, relationships, mental health, and communication, as well as political persuasion? You can think about how AI might be amplifying or hindering creativity and art, as well as many others. So without further ado, I want to dive into a roadmap to build your own research collaboration from the ground up. So I want to start by talking about how to ideate clearly. If you have an idea, you are more likely to attract the best collaborators if you make it very crisp and clear and understandable. And so I'd suggest you write out your idea in a one or two pager maximum. And that should have a few sections. It should have the motivation, the methods, the expected plots. What are the metrics that you expect to measure things with? What are the axes of the figures or graphs you're going to generate? And what are the anticipated lines? Is it going up, down? What do you expect to see in that bar or scatter plot? And then what are the possible outcomes? If the experiment goes well, what do you expect to see? If it goes poorly, what's the negative result that might happen? Enumerate the different things that will happen, and as well as the potential users. Paint a very vivid picture for yourself, your collaborators, and your skeptics before you embark on this project. And that's going to lead me to lesson number one that I learned early from advisors of mine. You want to ask three questions of every research investigation that you embark upon. The first is a simple one. It's about novelty. If you were not to do this research project, will someone do this anyway in the next year? If the answer is yes, then I challenge you to ask, is it really beneficial to do this 2 months earlier than someone else, or to be in the race of doing it before you get scooped? What about what you're doing is novel, or you have a particular advantage in that, or you've honed the problem to a specific place that you think you might be one of the only people working on it, or working on the specific solution that you have? Even if you want to work on something that's at a highly popular space, you can find a variant of it that is more novel and unique and more long-term and maybe risky. The second question is the thing you're exploring informative, or rather, is every possible outcome informative? So if you're running an experiment and you have a positive result, the thing that you thought would work worked well, then that's great. But what if you have a negative result? Or what if it's no different than other methods? You should enumerate all these possibilities and you should pick an experiment that is most informative, meaning if it fails or the worst things happen, the worst outcomes happen, is it still interesting to the community because someone will now see it as a valuable negative result and it will steer their research in a different direction and they'll cite you and be influenced by you. Pick the most information providing experiments whenever you can. And lastly, pick something useful. Can you find the users now? Is there someone that wishes your evaluation set, benchmark, infrastructure, or result was already out so that they can build upon it right now? So rather than a post-mortem, you want to do a pre-mortem. And that means anticipate the criticisms and weaknesses of your work. Find your critics, or as they say, your reviewer number two right now. They're already out there. They're going to be assigned to your paper no matter what you do by the laws of reviewing. Go find them now. And if you're not sure who they might be, talk to your advisor. They know who the critical people in the industry are, who's thinking about this, who doesn't like this approach. Find reviewer number two. Before you even have started an experiment, reach out to them with a personalized email, ask them for advice and thoughts, and figure out what their particular issue is with your agenda. And I did this with my AI safe harbor work. We reached out to the companies because our work was innately a little bit critical of some of the things that they were doing. And we got the perspectives from the AI safety teams to figure out why they didn't quite agree or what they wished we would propose instead of what we were saying. And that really reinforced and solidified and rounded out our perspectives in ways that made our work much more defensible against any criticism. The third point is to recruit horizontally and vertically. What do I mean by this? Use your one pager to find people that are interested. Horizontally means don't let geography or institutional boundaries get in the way of finding your ideal collaborators. So we live in the world of Zoom, so that you can use it. Don't just go to the office next door. Find people that you want to work with from different departments and different industries and different areas across the world. But also recruit vertically. So you probably have an aspirational advisor. For me, at one point, that was Sarah Hooker and Marja. And I reached out to them to say, will you advise me or help me on these different research projects that I have with my one pager? I was fortunate at different instances, these advisors said yes. But also for those projects, I looked to recruit people that were more junior. What about senior undergrads or master students that really want to work on your project? Many of them are out there and waiting for that opportunity that was once you. So go and find these people as well. And if it doesn't work out, then they'll fall off the project. But if it does, you're going to find great collaborators and for now and the future. And also, obviously, recruit your reviewer number two. Find your critics. If they align enough and are willing to go with your vision, then do that too. Lesson number two I learned from Sarah Hooker is use interest forms. If you have a senior advisor, you can put a Google form together that gives a high level project description, Ask people for their name and contact, their position experience, time commitment, and timeline. What are they interested in? Why are they interested in your project? And what pieces are they most interested in working on? And from that, you can identify people that you might not have known before, but who have been really eager to work on this type of thing with you, and it will expand your boundaries from your known circles. So Cohere folks have done this a lot to great success, and I'd recommend it. Next is very important. Structure your incentives in a project once you have a team. Incentives really matter. So authorship is really a currency. Collaboration can amplify, but not dilute your contributions, and so be generous with it. People also care about experience. Interesting projects are appealing, and working with you and your advisors might be appealing. Those relationships are appealing to them. The impact they might have from contributing to an open source project might be powerful to them. The visibility of allowing them to co-present this work with you when it goes out, or take some form of credit, or even social media credit, or maintaining the living artifacts. All of these things matter, but it's important to also allow people to own a piece of the project. For the Data Provenance Initiative, the multimodal one, we subdivided teams into people who were lawyers, to the data crawlers, the text team, the vision team, the speech team, and each of them owned various figures and tables, deliverables that made them able to take ownership of their piece. Communicate early and clearly. Relationships may be the greatest long-term impact, so decide expectations early together, decide credit early together, timelines, meeting cadence, and responsibilities. Don't agree who's first, second, third author now. Agree on the process and the contingencies by which this credit will be subdivided later. So you don't remove the incentives for people to work hard and maybe have flexibility for some people to pull back and some people to lean in and really take ownership. Getting this done now will make people happy in the long run and push back against any confusion. The third lesson I want to talk about is that good advisors shouldn't just guide, they should also evangelize your work. So, as well as de-risking projects and maximizing impact, they should connect you with your critics and collaborators. They should uplift and, yes, even promote the release of the work and your career. Great advisors find the users and the interest for you because audiences are information flow is imperfect. Sometimes you have to go find the audiences, reach out to the labs that might be interested in hosting you in their reading group or as a presentation because they just weren't familiar unless you got 100,000 views on LinkedIn or X. It's important to help find your audiences and connect your communities, and your advisors can be helpful for that. Six, document your decisions. Shared memory is collective intelligence. Details will fall through the cracks, so write down your methods, your justifications, and what every person did in a living document over time. Lastly, I want to talk about artifacts and visuals. Sometimes the most impactful things that stand the test of time in your projects, beyond your relationships, are the visuals and the infrastructure that are reused. And so I would focus most on these. Focus on reusable infrastructure, the figures, the tables, the interactive dashboards. These are things that people continually revisit. Whereas only, 5% of people will really read, your paper and the minutia of it. Most people will take away the high level ideas. So it's important to encapsulate that well. And a picture is really worth 1,000 words. Um, Lesson number four, and this was really helpful to me to communicate my work, especially in large collaborations where you need to distill complex ideas that from many different people at once. When you're framing or pitching your abstract or writing your abstract, don't say what you did. Forget that. Start with why this matters. Describe what you found, why it matters, not what you did. As an example, this paper examines X in the context of Y. Terrible, boring, don't write that. Instead, write, despite recent advances, large language models struggle with X. It tells us why it matters. Or over here, we conducted 200 fine-tuning experiments spanning 20 languages, evaluated on 6 benchmarks. That doesn't tell me much. Instead, say, from our 200 experiments, we found clear evidence that. In other words, don't say what you did, say what you found and why it matters. That is why people read a research. They don't want to know a list of methodologies. They want to know what you found and why it mattered. Um, Lastly, I've consolidated some lessons learned from my mentors and advisors from across Cohere and a number of academic and industry institutions. And they've said things like the most valuable long-term impact is the relationships, incentives matter. Find the right incentives for the right people and share them. Find the right research problems because those will attract collaborators, and that comes from early iteration and discussion. Find your users and your critics early. Don't let geography and institutional barriers block your collaborations. Good senior collaborators, which you will one day be, will help you enable and evangelize the junior researcher's work. And to find collaborators you can use, I found Cohere and the Cohere Connect and other, Discord channels really useful to do that. Also, remember that authorship and collaboration doesn't dilute your contribution, it amplifies it. Um, And so I'll release these slides, and I would love to hear from you if there are others that I've missed that have been really useful in your collaborations and the wealth of knowledge that's in this Zoom call right now. But thank you so much, and yeah, feel free to follow me on X or LinkedIn for more of these. I'm going to post some, but I'm going to hand it back to Julia. Thank you so much.
Thank you. This was awesome. And I think there's something to learn from like at any stage. Like I want to go back to this presentation and like post it over my wall or something to be reminded because we get so stuck sometimes in the little details of research and like the higher level like direction. This was very, very useful. Thank you so much. We have lots of thanks and appreciation in the comments. I think there was already a question even says one of the best presentations and valuable lessons. So this was super nicely distilled. Um, there was a question wait, I have to go back to that. So Manuel had a question. What are some recommended ways to find research to get involved with? Um, if we're in a place where that research is not common and online research is the only way. So Britannia already recommended the Open Science Committee. Any other personal like recommendations from your side?
I'd recommend the Discord channels from Cohere, from Luther. Um, what Britannia mentioned also, it's tough, but sometimes social media, a lot of people on LinkedIn or X also reach out to people that you're really excited about their research. Say you'd love to talk to them. You're excited about, personalized email, you're excited about this work that they did. You'd love to pick their brain and ask them what they're working on next, or if there are people working on something related to what you're curious about. That's the best way. Conferences or emails, Zoom chats have been really beneficial to me.
Yeah, I like that you also said personalize the email because there's no, like, I think as the receiver of an email, you would be able to tell if that's a blanket email that was sent through AI, like an entire community. But usually people like to talk about the stuff they care about, right? So that is, yeah, that is the core that brings people together. Mm. Do we have any other questions? Britannia, where do we see that? Or is that just in the chat?
Yeah, I think,
Um,
excuse me, sorry. Yeah, no, I think that was the main
okay, good.
in there
Okay,
for
good.
Shayne. But yeah, I know there's
Okay.
lots of praises. It's hard to filter through the praise there and see if there's any questions. But yeah, that was a great presentation, Shayne. Yeah, I think everyone can agree that it was really insightful and really interesting.
Okay, we have one more question. How much do you think the background material or prerequisites matter regarding approaching the research problem before you ask for collaboration? I think this is alluding to like how much we need to prepare, like how solid maybe your proposal has to be before you reach out.
Uh, I think that you can actually reach out to people to discuss their research that's related and discuss your ideas and get their feedback before you even ask them to be a collaborator and just go from there. And then if there is a back and forth and there's mutual interest and you've honed your direction as a result of their feedback, maybe in the second meeting, they're like, actually, yeah, I would like to, I really like this research, or I'd love to advise, or I'd love to be a part of it or collaborate. So you don't have to in your first email, your first outreach, ask for collaboration. Get their perspective first and see if it's a good fit.
I love that perspective because especially if you're starting out, it's super intimidating. Like, how did these three answers that the three questions that you had there, like, especially the first one was like if you're not an expert in that area yet, how can you know? So just coming at it with like ask questions rather than answers is probably a good perspective for learning and like getting interest from other people at the same time. So that's a very good advice. Okay, Tanya is getting us ready. Thanks so much, Shane. This was like super highly compressed, condensed knowledge from our experience of many, many years. I think we'll all like this is creating huge impact right here. I'm looking forward to seeing like the slides again when you decide to share them. And yeah, thanks so much. And we'll move on now to lightning talks from the Cohere Lab side. We have a bunch of speakers covering various topics that we've been working on in the past year. I think this is mostly. You'll see it covers a variety of topics, and we'll have record rooms related to these. So if anything sparks your interest in particular, take a note. We'll have time to discuss these in detail. And yeah. Uh, you're first, Diana. Take it away.
Hi, everyone. Thanks again to Shayne for such a fantastic talk. It was very inspiring for me as well. Um, but I'm a member of the pre-training staff here at Cohere, and I'll be discussing my scholar project from the Cohere Scholars Program. So the subject of my talk is efficient multilingual adaptation via universal tokenization, and this is about a paper that we released earlier in the year. So as many of you here are, I'm sure, familiar, LLMs are severely limited by their language support. In terms of officially proclaimed supported languages, I have a chart here of the number of languages that these models support. And as you can see on the lower end with Llama, it's like even around 8 languages. I is really exceptional in that we supported 101, but this still pales in comparison to the thousands of languages spoken around the world. How can this problem be addressed? Pre-training your own model is extremely expensive and it's not accessible to the majority of people around the globe. This is the training costs of these model families over the years, and as you can see, it's grown to over $100 million to train some of these models. So the most feasible way really to expand language coverage of a model is to adapt a base model rather than training from scratch. So in this project, we decided to address the question of what relatively cheap interventions can we make early on in pre-training to enable better adaptation to new languages down the line, and also reducing costs, not having to pre-train a whole new model. In particular, can we use a tokenizer trained on more languages than just the pre-training target languages to improve language plasticity without compromising pre-training performance? So we experiment with two tokenizer variants. One we call the cluster tokenizer, but this is really the standard tokenizer approach. It's trained only on the pre-training target languages, which we call primary languages. Then our suggestion is to use a universal tokenizer, which is trained on all of the pre-training languages, including expanded languages that you may want to improve the performance of your model on in post-training. So these are the results of some continued pre-training experiments. And you can see that there's a huge boost in language adaptation without hurting the primary languages. The primary language performance is in the blue portion of the graph for each one of these clusters, and you can see performance is about the same. But in the white portion of the graph, we compare the model trained with the universal tokenizer versus the cluster tokenizer, and we see improvements of about 20 points in win rate, which is a massive improvement averaged across these different clusters. The universal tokenizer also enables adaptation to fully unseen languages. So the languages in the previous slide were included in the tokenizer training. These languages were not in the tokenizer at all, but still we see an improvement of even up to 5% higher win rates, which is pretty significant in this low data unseen language setting. We also experimented with changing out the tokenizer or expanding the tokenizer after pre-training. So adapting the vocabulary to the new languages that you want to support. This is called cross-lingual vocabulary adaptation. And we experimented with keeping the same embeddings and the new embeddings initializing them with the mean of the previous ones. And as you can see, it's not as effective as training with the universal tokenizer from the start, although it is an improvement from just using the cluster tokenizer. And for some future directions, there are a variety of different things that can be experimented with. For example, we used the GPT-4o pre-tokenizer rejects and the BPE tokenization algorithm. No big deal if you don't know what those are, but they're pretty industry standard. And this was a deliberate choice for our recommendations to be widely applicable, but they're not the most optimal for multilingual support. Another thing is we used a 3 billion parameter model. Do these conclusions hold at larger parameter scales? And for example, there's been a lot of discourse around tokenizer-free models, which are really just byte-level tokenizers, and there could be a comparison to be made there as to see which one's better for multilingual support. So I've kind of glossed over these, but we're going to have breakout rooms after these presentations. So if you're interested, I hope to discuss these questions more with you.
Awesome. Thanks, Diana. We're going to go ahead and hand it over to Daniel next.
All right. Thanks so much. And let's get started. All right. So for the ideation and collaboration aspect, actually, this started right after the Aya models came out. And I think what was interesting there is that it made such an impact on languages that weren't served at the time. So the next thing that we thought about is can we bake some language information in there? So the document on the left is actually an actual Google Doc that started with, can we add prefixes related to languages in the training and improve them? What ended up happening is that we had a lot of contributors. That's why it's empty, because the list is huge. But they came in, they left comments, some left ideas, and what eventually happened is we ended up with the paper on the right. That is a much broader topic of how do you kind of add information into your data so that it gives you more control. Okay, so what about the long tail? So most LLMs are trained on a lot of data, and they do extremely well on the high frequency use cases. But where they suffer are the rarer use cases, aka the long tail. Now, even though the model has seen this data, it sometimes doesn't do well because it hasn't had a chance to learn it as much. What people normally do is some form of prompt engineering, or they threaten a model's hypothetical family to get it to do something. We think that there's a better way to do it. We ask, can we optimize our training protocols instead to both improve these things and do better on underrepresented data? So to do this, we define a taxonomy of the markers like task, domain, language, length, and then we annotate our training dataset with it. So what happens here is that you have a prompt and completion pair, and then they go through this annotation phase where we use rules, dataset characteristics, and LLM tagging. And then you get these marker-enriched prompt and completion pairs. Now, three things to understand here is you'll see that a one-liner law joke in Spanish now gets annotated as a creative writing task in the legal domain in the Spanish language that's concise. You'll notice that these annotations are after the prompt and before the completion. And the third thing to notice is that although the completion has all of the tags, the prompt doesn't. And this is done very intentionally. This is done to teach the model not to rely on these tags at inference time. So if something is passed in, like we say the task is a creative writing task, the model still has to learn to kind of propagate it. But if it isn't there, the model still has to learn to generate the things that are relevant for the prompt. Like it's a legal domain, it's in Spanish, and it has to be concise. So the data is annotated and the model is trained. Now what? Now you end up with a model where when you prompt it, it first gives you a list of tags and then gives you the generation. So if you ask it for a palindrome checker in Python, it'll first give you code-related markers and then proceed to give you the code. If you ask it for a 3-sentence paragraph on the French Revolution, it'll first give you a list of appropriate markers like domain is social sciences, length of sentences is 3, and then give you a conditioned generation based on that. But because of the way we've trained it, you have this optional control mechanism now. So if you look at a marker that we did called length, the bucket that has concise, medium, and long, where concise is anything less than 300 tokens, medium is between 300 and 1000, and long is anything greater than that. In inference time, for the same prompt, right? Tell me about the French Revolution. If you change the length bucket from concise, medium to long, you'll see that the distributions change. So what this means is that with the same prompt, changing a single marker can lead to vastly different test time distributions. This shows control at inference. And the best part is that the long tail benefits the most. So if you look at Arena Hard win rates against Gemma 2 and look at what happens with the underrepresented subset, which is less than 5% representation, you'll see that although everything improves by 5.7%, the underrepresented improves by 9% absolute win rates. Similarly, in coding, where underrepresented tasks like translation and repair actually have the highest amount of relative improvement. All this to say is that there are these markers that we can map at training and then actually uncover gains at inference time. To end this, I think what I'd like to think about is, let's think about the base idea, right? The base idea is that there's all of this information that we don't bake into the data. So as follow-ups, what else is the model being forced to learn implicitly? Can we make it explicit? In terms of representation for markers, we explored a pretty flat list. Is there hierarchical representations that are richer? And can we adapt existing models post-training to kind of utilize this framework? I'll be in the breakout room. Make sure you drop by, and I'm looking forward to interactions. Thanks so much.
Thank you, Daniel. So we'll keep talking about multilinguality here. I'm going to talk about collaboration that ended up in a paper called Déjà, where we'll take lessons from machine translation to evaluate multilingual LLMs. So how this collaboration came into place is that like the bunch of authors that you can see here, we came together and said we want to write a paper together. That was it. Like we want to keep working together because we feel like there's something to be said. So there's some common experiences that we had. So Eleftheria and Shweta both did their PhD at Maryland University. So they were already working together a lot. Then while I was a Google Translate, they both interned during different years so that we created connection. And then I joined Cohere. And we also met with, and Cosme also joined Cohere, who was previously in contact with us through WMT, the Conference on Machine Translation. And then, yeah, Cosme, Marcia, and I were at Cohere, and Marcia has also done machine translation research in her PhD. So all of us shared a common background that we have done machine translation research in our PhD, and all had to move to, or not had to, but moved to research in multilingual LLMs. So we all had that path in common in different ways. So that kind of, and we had some common experiences, but also different views. And that brought us together like for a year, literally. We had like call, like, okay, what is there to be said in that space? So that brought us to like taking our machine translation lenses and looking at what bothers us in multilingual evaluation and turning that into something constructive. So this is the story of this paper. And because of that, it's a bit of a survey position paper. It's a bit of an unusual one, I would say. So we started by doing a survey of generative multilingual benchmarks. So these are not the typical multiple choice question answering benchmarks, but benchmarks that require generating whole text in different languages. Like there's various ways of evaluating that. And so things that we looked at is like, what's the coverage in terms of languages? How popular are different benchmarks? How much are they used? Were they translated with machines, with humans? Were they originally written in different languages? Who was involved in building this? What's the size? And based on that, so we had it starts with a survey, and what we find is that the practices and the benchmarks kind of lack nuances in reporting, reproducibility, standardization, robustness, and reliability. So overall, there's lots to be done in that space, let's say, and also like it is still very challenging if you work in multilingual LLMs to arrive at reliable results. So machine translation has had similar challenges, but more time to address them. So there's various stories that we tell in this paper about how machine translation research has addressed these. So we learned from that and we derive a checklist. So we have 5 different recommendations, kind of tips and tricks you can do relatively low effort when you work in the multilingual evaluation space. I linked the checklist here. And such things as when you work with synthetically generated data or translated prompts, try at least to optimize, measure, and report prompt translation quality to avoid biases. Given that lots of these benchmarks are, for example, very small, consider the test set size when you do your evaluations, maybe do some statistical power analysis. When you aggregate across many languages, how should which languages get more weight due to outliers or kind of other biases? So and what kind of other analysis can you do beyond that single score that the benchmark gives you for accuracy, for example? And one key part is to making progress as a research field in general is to increase the transparency of our evaluations. So we know that it matters completely how you phrase the prompt, how you phrase the prompt to an LLM judge, which version of an LLM judge do you use. So we as a lab have also started releasing our evaluations, for example, so that it's not just only reproducible in the sense that someone else can run the same model on the same benchmark, but the scores, the outputs are also there. So you can investigate that before having to rerun everything. So that's something that we suggest in this work. So some next steps to be discussed in the breakout room or beyond that. So one of the key parts that we don't really have yet in multilingual evaluation, I would say, is accessible tuning. So there are a few evaluation benchmarks with frameworks around, but they're not adopted across the bench. And something that we learned in machine translation is something like Sacre Bleu goes a long way for kind of unifying and robustifying evaluations and making sure that, robust reporting is easy and accessible. And what do we do, for example, with language-specific benchmarks? Because there's this bias towards adopting anything that's massively multilingual, meaning above 10 languages or more, but these might not be the most relevant benchmarks for each of the languages. So that's a big disconnect as well. And we definitely need more metrics research, especially regarding LLM judges. So we have actually, as a follow-up this work, we organized a share task at WM225 focused on, so that's the conference that traditionally focuses on machine translation. We ran a share task on multilingual instruction to models. No one participated. So I can still show the disconnect between these two fields. But we turned this into a benchmarking opportunity, and we have released all the evaluations from a bunch of models, like baseline models, multilingual, not baselines, by top multilingual LLMs across these different tasks. And there's a lot of data to be analyzed and insights to be derived from. So looking forward to discussing with you later. And now we'll pass it to Virat, who will be talking about code.
Awesome. Thank you, Julia. Hi, everyone. My name is Virat. I'm a member of technical staff on the multimodal team at Cohere, and I'm going to be talking about a research scholar project that I did last year called To Code or Not to Code, Exploring the Impact of Code in Pre-Training. So modern day LLMs devote a significant proportion of their pre-training data mix to code. And even when their main aim is not code generation, there's up to 20%, 30% of their mix is code. So we wanted to systematically study this. And we asked the question, what is the impact of code data used in pre-training on a large variety of downstream tasks beyond code generation? And also, as an addition, we wanted to understand which phase of pre-training and how much of code data would be useful. So I'll quickly talk about the data sources and the evaluation. So we had 3 data sources. One was a natural language corpora, where we completely stripped out any GitHub code related or Stack Exchange data. We had a code corpora that was from the stack, and additionally, we augmented it with some markdown data, a synthetic data set, and code adjacent data like Stack Exchange. Finally, we had a cooldown set for the cooldown phase of pre-training, which is very high quality text and instruct style as well. For evaluation, we had 4 task suites: natural language reasoning, which tests things like general intelligence, sentence completions, and others. World knowledge, which tests sort of memorization, retrieval, and QA capability. Code task, which tests function completion in Python. And then generative win rates to sort of understand how open-ended generation performance looks like. So in terms of ablations, we first started with initialization. If you see balanced here, it means it's a equal 50-50 split between natural language text and code data. And if you see balanced arrow text, that means it's initialized with a model that was trained on a balanced mix and continual pre-trained on text. And we find that initialization with code pre-trained models gives you a benefit over initializing from text-only models or from training from scratch. We find that these findings hold when we scale the models from 400 million parameters to 2.8 billion parameters as well, and the same trends in terms of which model is the best, which over here is the balanced text model across the 3 task suites. Next, we look at data ablations. So first thing we look at is proportion of code, where we increase the proportion of code in the data mix from 0% to 100%. And we find that there's a sweet spot in terms of overall performance, where including about 25% of code gives you an improvement in natural language reasoning performance while not really sacrificing performance elsewhere. The next thing we looked at was properties of code. So here we added different types of code and code-related data. So this is synthetic data, markup style data, and code adjacent data like Stack Exchange. And we found that these have improvements for natural language reasoning, but can sometimes inhibit code performance, except for the synthetic data, which showed improvements in both sets of tasks. This synthetic data finding was a little surprising, the extent to which it helped improve things. So we wanted to study if that transferred from initial pre-training to continual pre-training, and we find that holds as well. Finally, when it comes to phases of pre-training, we talked about training from scratch and continual pre-training, but we haven't talked about cooldown. So we took our best model, the balanced text, and performed cooldown on it. And we had no cooldown with code and without code. And we find that including code in the cooldown phase provides significant improvements across task categories. Not only across tasks, but also actually helps improve generative quality. And that model won its win rates by a decent amount of margin. So I guess the takeaways from this talk might be that we find across all scales that code provides critical building blocks and improvements to performance on non-code tasks and is vital for generalization. Including code in all phases of pre-training is beneficial, and that synthetic high-quality code data provided an outsized impact for overall metrics and generative quality. I'd like to take a minute to talk about what's next, which maybe verification, better methods to generate synthetic data, further diving deep on properties of code, or what this looks like in post-training, what sort of capabilities are available or not available depending on the code data. If you want to discuss more, there is a brainstorm breakout room that's there, so please join me there. I also want to talk about how this sort of project and collaboration came out to be. It started with me being rejected from the Research Scholar program and DMing Sarah, who suggested I join the community and volunteer. And so I became a volunteer on IA project, worked with Amit and Shayne. And that sort of led me to being here talking to you today about this project and a member of technical staff at Cohere. So I'd like to end by thanking my collaborators and mentors who were part of this paper, without whom this work wouldn't have been possible. So Yikshuan, Raymond, Adrian, Ivan, Asir, Matsya, Ahmet, and Sarah. And I will pass off to Shivalika and Oliver. Thank you.
Uh, hi everyone. I'm Oliver. Thanks for having me here. Today, Shavlika and I can talk about our paper leaderboard illusion. So in this paper, we carefully audit the most popular leaderboard platform in our community and raise some serious questions about the transparency and fairness of the leaderboard of such kind. So yes. So Chatbot Arena is open platform that benchmark language model using crowdsourced pairwise human preference. So each time you enter your prompt, you get your anonymous response. You get your anonymous response, and then you have to pick which one you like. So based on the large number of voting history, the platform will give a ranking of we call leaderboard of models on the platform based on the user preference. So as many of you know, this has become one of the most influential leaderboard in our field, although it's widely regarded as a successful and go-to benchmark. Our own experience with submission gradually raised some serious questions, and those observations ultimately motivated us to conduct this systematic study on the leaderboard. So after months of tracking and analysis, we can summarize our key findings down to 4 main points. First is there are serious undisclosed private testing in the platform that many people don't know. So this lets model providers handpick the best performing variants to put on the leaderboard, especially for proprietary model provider. They work more closely together with the Chatbot Arena organizers. And the second is there's a big disparity in data access, which also significantly benefits a proprietary model provider because they are testing more private variants, which lead to our third point. Chatbot Arena has a very specific data distributions that large model now these days with billions of parameters can very easily to learn. So this means there's a risk of overfitting to the benchmark if the model developer can get enough data. And finally, we found that Chatbot Arena has been quietly removed open source model, which make open source model either less likely to be sampled or stay in the platform for a very short period of time, making them even harder to compete with peers. So next, I will hand over the floor to my colleague Shivalika.
Yeah, thank you, Oliver. Oliver just highlighted the issues we had identified with Chatbot Arena, but all of these issues are very much addressable. Chatbot Arena has been a useful platform so far for evaluating LLMs, but these are just some issues that we encountered with the way the platform was being run. But these are addressable. We provide some recommendations in our paper with respect to addressing these. With respect to private testing, we recommend that providers are asked to disclose the results of the private test that they are conducting. We also recommend putting a cap on the number of private variants that providers are testing. With respect to deprecation, we recommend that transparency is provided into which models are being deprecated more clearly. We recommend ensuring model removals are applied equally across the 3 different model categories of open source, open weight, and proprietary. We also recommend implementing more fair sampling rates, reverting back to the active sampling rule that was originally proposed by the ARENA authors, but is not actually followed in practice. With respect to future directions, some of the straightforward directions could be around studying effects of adversarial voting for crowdsourced evaluation platforms like Chatbot Arena, which we didn't cover as part of this study. You could also extend the study to other crowdsourced evaluation platforms. Recently, there have been new launches like Compare AI was launched recently as a French LLM leaderboard. And also, can we go beyond like pairwise comparison of LLMs and think about other dynamic evaluation approaches? I would recommend checking out our paper for more details. There's also a fun MLSD video on it that I recommend checking out.